Alright, so I guess we're having an unexpected part 2 of this tutorial because I accidentally binded the space key to start and stop record. So anyways, if you go to the G-code space Wikipedia, it'll take you to a Wikipedia page which documents what all of the commands in G-code do. So if you ever have a question of a command, like say I want to know what M220 does, you just do a control find and say, oh, M220 is a set speed factor override, which is essentially how fast it reads through all of the commands. So back to what we want to do is we want to combine my example G code with the .nc code that we generated from easel. So if we open up my tutorial code in WordPad, because I like WordPad better, you will see that G code is generated in simple format. It has a header, a main body, and then a footer at the end. And what the header and the footer essentially do is they declare how all the variables and stuff and all the commands are going to be interpreted by the machine and sets specific rates and stuff. So now if we go and we open up the .nc file that they gave us with WordPad, we can see that their header essentially doesn't have much there because they're going to use it with their specific machine that already has all the variables declared the way that they want it to be, but we actually don't want that. We want to put in our specific command. So we're going to delete their header, give ourselves a few spaces for some room, and we're going to go to my example. I actually think this is the wrong file, so I'm going to close that. If we go to my example, close that as well. Got everything open from the first take. If we grab my header for my example code and we paste it into the code we generated, now we're essentially going to declare everything we want. And so just a quick rundown, we're doing a G92, which is, okay, where we're at right now is the origin. We're setting it as the origin. Then we're going to do it again just to make very sure we're at the origin. We're setting X0, Y0, Z0. We're going to do an M201, which is going to set the max acceleration. And these are values that I have found work pretty good with our machine, with the specific machine that I built. And then E is setting the extruder value, because this Marlin is meant to run 3D printers, so they have extruders. And so when you enter this command, it's going to look for you to declare all the values, including the extruder. So we're just going to declare a dummy extruder values, even though we're not using an extruder, just to make the code happy. Then we're going to do an M92, and what that does is we're going to set the axis steps per unit. As you can see, I've got a really big number of steps per unit because I want to have 1 inch is my default unit. This also works with our movement commands we set. We set our default units and our default feed rate and all that, and then we're going to now declare our axis steps per unit to make it all be one unit is 1 inch. Also, you need to note that the Z is a 10 power less than the X and Y. And this is because Marlin is expecting you to have a very small increment in speed for your vertical commands because they're meant to be used on a 3D printer, which normally moves the Z-axis with a threaded rod and the X and Y with a belt. So it's expecting our Z to move a lot slower than our X and Y. So we're just going to give it something that it is expecting, because using any value bigger than this generates errors, and at least that's how I found. Then we're going to do an M566, and this sets the allowable speed change. These are just values that I found work. I haven't really messed around with these too much, but it just works. Just use those. And then an M220 is, like I showed before, is setting the allowable speed factor. And so there's two main ways that I found that you determine the speed of how fast your machine is going to cut at. One is with the feed rate command, and one is with this S command, the speed. The feed rate you have to hard code in every line of code, so you can't change it while the code is running. The speed command, though, you can change how the code is running because you only declare it once. So if you start cutting and you realize you're cutting too fast or too slow, you can go into Pronterface and change that by typing M220 space S and then our speed we want to change it to increase or decrease the speed. I usually like to start it off slow at about a speed of 5 and then ramp up the speed once I find that the machine is able to cut faster in whatever material I'm cutting with. It's safer to start slow and ramp it up by manually typing it in than start too fast and then bog down your machine and start skipping steps and that kind of thing. But anyways, now the first two lines that easel does is we're going to move to our first position. We're going to move to our first position, and then we're going to drop our cutter. Now, easel has it set up that it sets the home by hitting a sensor to the build plate and then backing up its command. So we want to actually delete that. We're going to start it up in the air. Give it a little bit of space here. Then it's going to move to where we want to start cutting and then drop our head down to start cutting. And what that looks like on our thing is we're starting at origin. We're going to move over here. We're going to drop down and start cutting. And so what we want to do is easel uses it, since they use that the build plate is 0 and we're not using that, we need to change how all of the plunge rates are interpreted. And so since I want to cut a 1/4 inch into my piece, I would put, instead of a Z negative 0.25, I would put a cut of 2.5, which is a 1/4 inch. However, I don't want to do that. I want to actually do a cut of 5.0, which is 1/2 inch, because I want to set the home of my cutter to be a 1/4 inch above the piece I'm cutting. And this is because if there's any variation in the height of the piece you're cutting, or you lose one step or anything small, as your head is translating from one spot to another, it'll start cutting just slightly into the top of your piece where you don't want it to cut, and we don't want that. So to give ourselves a margin of error, I use a 1/4 inch piece of MDF as a spacer, and then just always set my head to be a 1/4 inch above the top, the highest spot of the piece I'm cutting. And so I just add that into my command. So now we want to change the plunge rates to be what we want it to be. We want to find the Z negative, let's see, 0.25, and we want to replace that with our Z of, and since we have our machine oriented that positive is down and negative is up, the exact opposite of how easel is oriented, we want to drop it down to 5.0 inches. So we're going down 1/2 inch, which is actually cutting a 1/4 inch into the piece. So we're going to replace all. Okay, we're all good. And now, as you remember, we have 0 as the height that we're translating in, versus Inventables wants you to go up a little bit. And so instead of having it be 0.15, a little too many zeros there, 0.15, okay, we want to change it to 0, because we set 0 as the height we want to translate in. We're going to replace all. It's going to say, okay, we've finished that. So now we want to change our feed rates. Now, these feed rates are auto-generated by our easel. In here, those are the feed rate and the plunge, so you would want to change it to 100 and 100 if you want, but I found it's better just to leave them wrong and change them so I know they're right than relying on easel to auto-generate them for me. So what we're going to do, we generate it with 30 and 9, so we're just going to have to do another find and replace, finding a feed of 30.0, and we're going to replace it with what I found is a good starting speed, a feed rate of 100. If you're cutting a harder material, you might want to start with a feed rate of about 50, and then words fumbling. Anyways, you want to experiment with changing the speed as you're cutting, and then just start with a slower speed rate. But I know I'm cutting a soft material, I'm cutting pine, so I can start with a speed rate of 100, and it's going to work pretty well. Replace all those, and then I'm also going to do the plunge rate, which is 9.0. I'm also going to change that to 100. Replace all good. You might want to experiment with a slower plunge rate than your cut rate, just because you're having to jam a bit down into the wood instead of just move it side to side, but that's all up to you. So now that we got our feed rates, our depth, our header all set, all that we have left to do is change the footer. And that's the command that's going to run at the end. So we're going to go back into my example code, go all the way down to the footer. We're going to grab the footer, do Control-C, come back over here, and grab their footer, and do a Control-V. And so what it's going to do, you're going to do a G20, a G90. We're going to move our cut head back up to our translating height. Then we're going to move back to our home. Then we're going to pause for a second, and then we're going to say, okay, we're back at our home. We're going to declare ourselves at our home. So that means then if you're going to want to do a follow-up pass or run another bit of code, your machine knows we're back at home, and then it'll continue right from where it left off. All right, now that that's all good, we need to save this as a G code, because right now it's a .nc. So WordPad is actually pretty picky with saving as other file types. So we're going to just grab it all, do a Control-C. We're going to open Notepad, paste it all in, and now we're going to save it as, I'm going to save it to my desktop. You first got to change it to all files, because you don't want to save it as a text file. Now I'm going to save that as tutorial code cut thing .g code. The .g code is important because that's telling it that when we upload the file, it's saying it's going to look for a G code so it knows everything's formatted right. And we're going to say, yes, we have a G code. Everything's good. Go ahead and run it. So now we're going to save it to the desktop. And then we're good to go. But first, what I'm going to do is I'm going to open the code back up and make sure everything is as I would expect it to be. I'm going to drag it down here, open it back up with WordPad, say to everything's okay. I got my header. I got my first movement command. I got all the rest of the movement commands. I've got a footer. Comes back to the same spot. Everything looks good. Now I'm ready to go print it. So that concludes this video, and now I'm going to make another video showing, once we got the G code, how to put it in Prawn Interface and then cut it. So stay tuned for the next video, and thanks.